So both inorganic and organic molecules are really important for living things. So salt's really important. You guys need sodium chloride. You need salts and other inorganic molecules to do things like send signals through your nervous system. But you also need organic molecules to make you up. And you don't have to draw this, but that's a sucrose molecule. Carbohydrates, or you guys probably heard them called carbs a lot, are organic molecules. And we're going to hopefully get to them a little bit today. So yeah, we're going to focus on organic molecules for a little bit here. Okay, so polymers. There are organic and inorganic polymers. We're going to focus on organic polymers. But polymers is just a word for large molecules that have a lot of identical subunits. So if you guys think about DNA, if you kind of recall like learning about the structure where there's nucleotides making up the DNA, it's a whole bunch of identical subunits and it makes up one large molecule. So that's an example of a polymer. Proteins are examples of polymers. So you guys can see in this left thing here, I've got amino acids, and they fold up and they make different proteins. So proteins are polymers made up of lots of amino acids, which are the subunits. We can also call those monomers, just for fun. So yeah, it's just a little bit of terminology that we'll be using. Oh, do you want me to stay on this one? Yeah. Sorry. So these pieces of terminology, biology, it really sometimes is like learning a second language or a third language or fourth, like however many languages you have, and kind of adding another one. I would really recommend making flashcards or doing some other memorization tactic that you have to just remember these words. So we can make or break polymers into those subunits. So we can break them into their subunits using something called hydrolysis, and we can make them through a process that we call dehydration synthesis, which sometimes you might also refer to as polymerization or condensation. I'm going to say dehydration synthesis in just to be consistent, but if you see those other two words, just know that they are the same thing. What does the word hydro make you guys think of? Water. Yeah, these both have to do with water. All right, hydrolysis. So remember this one by hydro equals water. We're adding water to something. In a hydrolysis reaction, we actually break the bonds and we turn something into smaller molecules. So starch is an example that we can break into smaller carbohydrates like glucose. And we'll talk about how glucose is used in your body later when you mix it with water. So starch, you add water, it breaks into glucose. Proteins, you can break them down into smaller peptides or amino acids by adding water. So that's what this diagram on the bottom is. You've got a larger protein up there, and then you can see plus H2O plus water. It breaks that bond, and you end up with two different subunits. So that's hydrolysis, is breaking things down by adding water. You guys did well in this. Okay, so that's hydrolysis. So we're going to go the opposite way. So things can undergo hydrolysis where you add water. We can also take away water. Do you guys know what that might do? Dehydration synthesis, yeah. And it's just going to be the opposite of this. So it's going to be taking things and like adding them together. So dehydration synthesis by removing water. So you can see in the top there, we've got two separate things, a little plus between them. We're going to add those together, take water away. So water, the two H's and the O there in the middle are leaving. And then a bond is formed and we get a polymer. So we're forming polymers by taking water away. Okay, so hydro, add, break, dehydrate, take away, form. Okay, so that is polymers. We're gonna talk about carbohydrates now. Yay, carbohydrates. Oh, and I'm gonna pause that.